Hi, this is Marwa, and today we will do another video about radical expressions. We had 3 videos before, one about simplifying radical expressions, one about multiplying radical expressions, and the last one was about dividing radical expressions. Today we will see how we add and subtract radical expressions. We have 2 groups of examples. The first group will be simple examples to see how we can add or subtract if we have the same radicand and the same index. The second group of examples, we will see how we will need to simplify sometimes first before we can add or subtract, like the examples we have here in the front page. So let's look at our first group of examples. Now, before we go through the examples, let's read the rule we have here. The rule says we use the distributive property to add and subtract like radicals. We have a nth root of x plus b nth root of x. Now take care that for us to add or subtract, we'd have to have the same index, the n here, and we have to have the same radicand. Like this is x, this is also x. And in this case, what will we do? We're going to take the nth root of x as a common factor and simply add a plus b. We do the exact same thing with subtraction. We're going to take the nth root of x as a common factor and subtract a minus b. Now let's see how does this work when we have examples here. It says here simplify if possible, and I have 6 cubic root of 3 minus 2 cubic root of 3. Both indices or indices are the same, and the radicands are also the same. Radicands are number under the radical. Now, what am I going to do? If I want to follow the same rule, I'm going to take the cubic root of 3 as a common factor, and I'm going to subtract 6 minus 2. You will get 4 cubic root of 3. Now, once you understood what actually you do, you don't need to write this step. You will say that 6 cubic root of 3 minus 2 cubic root of 3 is equal to 4 cubic root of 3. Now let's look at our second example here. It says 4 square root of 3 plus 4 cubic root of 3. Now as you notice here, we have different index. The index here is 2, the index here is 3. If they're not the same, then there is nothing you can do. So simply it's not possible for you to add. For the last example we have here, 8 square root of 3x minus 5 square root of 3x. Although we have a variable, but because they are exactly the same, we have the same radicand, we have the same index, I'm going to do 8 minus 5, which is 3 square root of 3x. Now this was a very easy group of questions. So let's look at our next group here. Now here we are required to simplify, and for the first question we have square root of 18 plus square root of 32. Now the radicands are not the same. We agreed if they're not the same, we cannot add. However, because these are not in simplest form, and we know we can simplify, we can't decide whether we can add or not until we simplify. Now how do I simplify? Same way we did in our previous videos. I'm going to find the prime factors of 18, which are 9 times 2. 2 is the prime, so I'll keep it, and 9 is 3 times 3. Both of them are prime. So I know that the square root of 18 is 2 multiplied by 3 squared plus 32. The prime factors of 32, I already know that they are 2 to the power of 5. We did them multiple times before. And now I'm going to simplify. Now I can take the 3 squared out, because square root of 3 squared is 3. So I have 3 radical 2 here for the first term. For the second term, this is 2 to the power of 5. I can take 2 to the power of 4 out. The square root of 2 to the power of 4 is 2 squared. And I still have radical 2. I can simplify further this last term. So this is 3 radical 2 plus 4 radical 2. And your answer is 7 radical 2. So again, although I don't have the same radical, I can't tell whether I can add or subtract or not until I simplify. Now let's look at our next question here. I have 14. Now the difference between this question and the one before, that we have a number outside. So let's see what we're going to do with this number. I have 14 square root of 20. Well, 20 is 4 times 5, which is 2 squared multiplied by 5. Don't need much of factoring here. 125 is 5 cubed. Now let's simplify if we can. So I have 14. I have 2 squared. I can take that out. So it's times 2. And this is radical 5. Minus 3 times 5. Radical 5. Because this is 5 cubed. You can take 5 squared out. We will end up with 28 radical 5 minus 15 radical 5, which gives you a value of 13 radical 5. Now let's look at the other question here. I have the fourth root of 32. Well, 32, as we all know, is 2 to the power of 5. Plus fourth root of 48. Well, we might need to see what 48 will lead us to. Well, 48 is 4 times 12. 12 is 3 times 4. 3 is prime. 4 is 2 times 2. Both are prime. And 4 here also is 2 times 2. Both are prime. So I know that 48 is 2 to the power of 4 multiplied by 3. Now when I simplify, I will get 2 fourth root of 2, because this is to the power of 5. I'm going to take 2 to the power of 4 out, and I have only 2 left, plus 2 fourth root of 3. Now this is the point where I check. I do have the same index, but I don't have the same radicand, so I cannot simplify any further, and this is the simplest form of this question. Our last question here has 3 terms. Each one of them is a cubic root, so apparently I might be able to simplify. Again, we will use prime factorization. 250 is 125 times 2, so this is 2 multiplied by 5 cubed, plus, and cubic root of 54. Well, we might need to check what 54 is. 54 is 9 times 6. 6 is 2 times 3. Both are prime, and 9 is 3 times 3. So I have 2 times 3 cubed minus cubic root of 16, which is 2 to the power of 4. Now simplify each one of them. That will give you 5 cubic root of 2 plus 3 cubic root of 2 minus 2 cubic root of 2. Again, this is to the power of 4. I'm going to take the cube out and leave the 2. 5 plus 3 is 8, and 8 minus 2 is 6, since I have the same radicand and the same index, so I know my answer is 6 cubic root of 2. Now, I hope this has been helpful and easy for you. We will every time check for if we have the same index, regardless whatever operation you want to do. For multiplication, division, addition, or subtraction, you have to have the same index to be able to perform the operation. However, addition and subtraction require one more thing. You need to have the same radicand as well. We can't tell if we have the same radicand or not until we simplify first. Now that we have seen how to perform all types of operations on radical expressions, our next video will be about binomial radical expressions. I hope this has been helpful, and thank you so much for watching.